Hey everyone, good morning. So today we would be discussing about how we did benchmark performance evaluation of dynamically generated DAGs. And before we start, I would like to say that it's not only for the dynamically generated DAG, we can consider this workflow or whatever we would be discussing. We can also apply the same principles to the DAGs which are not dynamic in nature. Before we start, I would like to discuss a brief about agenda. What is the motivation around this? Then we would discuss around some benchmark principle, which we looked at, some do's and don't. After that, representative workflows, right? What kind of workflows we looked and tried implemented, and obviously metrics. What kind of metrics we used to ensure and to check we should be evaluating on, right? Then we would briefly discuss on the implementation, how our implementation looks like. There could be obviously different ways of implementation by different ways, but we would like to discuss and share ours with you. Next thing, we would be having discussions around result, what we did, what we compared against, what were the values, and we would share that. And last not the least, the next steps. That is very important as far as, because this talk is not about what we did. We wanted to ensure that this is a stepping stone towards performance benchmark evaluation. We need to take one step further. So we would be discussing around what are the next steps, how you and we can contribute and ensure we do a great job in performance evaluation. So that's brief around the agenda. Okay, so before even I start about motivation, I would like to know from all of you here that how many of you do run benchmark evaluation on your DAGs in your respective environment? So on regularly or maybe just after upgrading to a new version, or if you are a new user, how many of you do benchmarking of DAGs? I was only able to see one hand, so that is the core motivation, right, for us as well. Saying that, we do functionality evaluation pretty often, regressing that we are not breaking the prior things, ensuring the new things are working, but we were not focusing a lot on performance. These things are only taken care when it hit in production, and then we put our focus on it. So that is a core motivation for this talk. Now talking about dynamic DAGs, as most of you are aware of Airflow, it's pretty simple and there are different ways to create dynamic DAGs in Airflow. It's as simple as just writing a DAG, putting some loops, and you can have one file which can generate it to multiple DAGs. Now we do have more ways, more tools to create dynamic DAGs in Airflow. One is DAG Factory. You can just do pip install DAG Factory, and you can have a YAML file which you can configure. You can provide different task IDs, dates, parameters, and you would have dynamic DAGs with you, right? This is one of the way. We have Cosmos. We can do just pip install astronomical Cosmos, and with the help of that, we can convert different DBT pipelines into Airflow DAG. Now, there is a lot of high adoption of these dynamic DAG tools. We have seen at least 20 million downloads in PyPy for Cosmos and DAG Factory. And there are a lot of dynamic DAGs which runs every day or month in Astro, right? So with such a high usage and adoption, it takes that we consider performance not lightly, and we should have some standardization around that. I would now like to discuss, right, how the dynamic DAGs or the DAGs get reparsed in Airflow, right? In this workflow, I would not be going into the detail of how it's done and how the task is got to scheduler, executor, and worker. What I would like to emphasize is that when DAG processor do parsing of the DAGs folder and get all the DAGs in the metadata, it's not only that. Even every worker has to process, parse DAGs from the DAG folder. Now, in the case of dynamic DAGs, it can be more serious, right? What do I mean by that? There could be some consequences. There could be more consumption of CPU, more consumption of memory, and there could be longer parsing time, right, for dynamic DAGs. And this can very well like correlate to different timeout issues, longer queue times, and also resource consumption, right? So what I mean to say is with dynamic DAGs, it matters most to do performance evaluation. We have seen multiple issues in terms of that the DAGs are stuck in queued state, DAGs are not visible on Airflow UI, right? So these are the motivation factors which are contributing to it, right? Now, talking about who cares about performance, I think each and every one of us, whether they are developer, they are users, they are stakeholder, they are like in sales production, everyone does care about the performance. If you are an end user, definitely it can impact you financially that your workflows are not working properly. It can impact your day-to-day workflows. We as an Airflow developers try our best to ensure that with every sequential version, we work on performance and ensure that the performance is not impacted. For sales, I believe that one of the roadblocks, right, this could be one of the roadblocks that if let's say you are working on a project and your company uses X Airflow version and you want to upgrade to X.1, right? So first thing you would ask that whether my deployment, whether my workflows would work with same efficiency or not, right? And right now there are different ad hoc ways people do that, but no standardization. So it would also help sales teams to like convince the customers that yeah, this is the metrics, we did some run test on this version, and this is the new one. So it will boost and give confidence to people to migrate to the newer Airflow version and help in adoption. And same for the product team, right? It also matters that the competitor of Airflows that we can compare against and see how we are going around that. So everyone cares about performance in and all, right? But current situation, as I said, that there are no standard benchmarks, right? There are people are doing ad hoc performance evaluation, but there are also lack of automation. Workflows are manual. There are different ways. So in short, we want a system in which we have an automated way of doing performance evaluation, where we can not only see the current version's performance, but also have a trend, like what was the performance on this version going to this version, which can always boost up the confidence and also helps in adoption of Airflow. Now, after that, the second thing is benchmarking principle. So this is not really tied to Airflow. I would say that this would be tied through performance evaluation. We should have some do's and don't. What this is as per us, but there could be different things also, which we would like to hear from you as well. So first thing is we need to ensure what we are measuring for, right? Why we need to do performance evaluation. Do we need to do it for throughput? Do we have to do it for latency or resource uses? And try to ensure that whatever evaluation we do, that should be as per real scenarios. Why I'm saying is because I have by myself tested some performance benchmarks with some synthetic environment variables or synthetic use cases which does not help, right? You're doing the same stuff, but you're not having the real world scenarios, and then all the efforts go in vain because on production there were some other use cases. So always try to do performance with realistic use case, right? And ensure the motivation. What is your motivation? Finding the bottlenecks that your tasks are not stuck, your workflows are seamless, and also comparing against the previous versions as a baseline. So in short, we should have a clear objectives, right? Same as workflow, we should have load as well, which should be realistic, right? We see that in performance, there are a lot of ways people try to create dummy data using multiple queries, right, or having dumps, right? But that doesn't help in most of the cases, right? Because in real use cases, there could be some scenarios which can overcome this, and then you have to redo the things again, which we don't want. And also, whatever process we follow, we should ensure that it can have test the typical workflow, but also the scalability up till when we can scalable, right? So we should know that what is the limit of our test. On that, right, I would say environment consistency. It's also very important and related to the last slide we said, right? We should try to create an environment which is as close as to the prod environment, because doing this in dev environment can have different repercussions, right? In terms of that, we could have some other things, other background jobs, which might impact and do not give the true results. So try to ensure that your environment is as close as to prod. I'm not saying that we should always have prod, but we can create a staging environment, which is kind of a replica, right? And we can mimic. So that is something which we should always consider doing the performance evaluation, right? Also having some configuration which is as close as to the prod. So to summarize, I would say that we can just consider this as a benchmark experiment life cycle. First, we have pre-process stage in which we create an environment which is isolated, as close as to the prod. We can have our whatever product we want to test on, install that with the same configuration, and then run our experiment, right? And post-process, collect our metrics, right? Whatever ways we want to store our artifacts. And then the important thing is doing the post-process, that we clean that thing, because the main goal is the automation of this, and we want to just ensure that whatever we did, whatever configuration we made are now back to normal so that we can rerun again. So yeah, these are the some benchmark guidelines I would like to discuss. And now I would hand over to Tatiana to talk about our representative workflows and what exactly we did to do our evaluation.
Thank you very much, Rahul. So how many people in the audience have used DBT, Data Transformation Tool? I will be using some examples of this, but to those who haven't used, imagine you could build workflows, but instead of using Python files like in Airflow, you could just write a bunch of SQL files and some YAML files, and that would build some workflows for you. And this tool is as popular as Airflow right now, especially among data practitioners. Many times data analysts may not feel comfortable using programming languages like Python. So this has allowed many, many professionals to create transformation workflows. And we started trying to solve, so I don't know if you noticed those issues Rahul showed, where customers were complaining, my DAG doesn't show in the UI, or things are just taking too long. And that's actually, those were support tickets related to Cosmos, which is a tool that converts from the SQL files from DBT into Airflow DAGs. So that's where most of our problems started. But Astronomer has been facing this sort of issue throughout our history, regardless of the tool being used. And when we started building this tool, we had this pipeline, which is quite simple. So you have 3 scenes, which are just data sets that are loaded into a database, and then you have 5 transformations after. So you have some dependencies across those tasks. It could be written in any language, in any orchestration workflow tool. But this was written in DBT, and we converted to Airflow using Cosmos. And during a long time, this example that's called Photoshop has been our go-to example. It's simple, it's easy to understand, we could troubleshoot behaviors in Cosmos and everything. But do you think a 5-node DAG is representative of what our customers have? Who thinks this is representative? Raise your hands. Okay, so again, no one raised the hands, because this is clearly not representative. So when we see those tickets, many of those customers have workflows with over 1,000 nodes. And this is what we were developing against. So quite limiting. So we thought, okay, we could create some artificial workflow. This will clearly be more similar to what our customers have. So one of the developers of the team by the time built this tool that you could, this script where you could say, create a DAG for me with, I don't know, 100 nodes, 1,000 nodes, and it would do something like this. But this, again, is not very representative, because each of those tasks is just actually inserting one row to a table in the database, so it's a very, very simple transformation. And the dependency is fully linear. So one task waits for the other task, for the other task. And this is not so common in most workflows we observe in production. So after lots of attempts, we decided, okay, there must be some good DBT projects out there which we could use to try to have more representative use cases. And there were. So we found many interesting projects, but most of those we couldn't just run. They depended on sources that were preset, they depended on data that wasn't available, they used very old versions of DBT, or there was something missing, until Pankaj Kotti, who is over here from my team, found this project by Google. So this is a DBT project that goes to BigQuery, and it has around 200 nodes. You can see that the UI, it's not the easiest to see. And it takes a certain amount of time. Some transformations may take almost 1 minute. You could configure seeds. So you felt, okay, this is the closest we can have right now, and this is better than what we had. So let's try to do benchmarks and analysis using this. As Rahul mentioned, we needed to specify which would be the metrics. What were we trying to optimize for? So we know customers have all sorts of issues. They do have issues with DAG parsing, for instance. This is a problem we tackled a few times in Cosmos. But they also were complaining. They were saying, this tool is not working for me. If I use dbt CLI locally in my MacBook, my pipeline runs in 1 minute. If I try to run in Airflow, it's taking 6. Why? Why is this happening? So we knew for sure we needed to improve DAG runtime. That was something we needed to measure, we needed to be able to control, and we needed to optimize. Task throughput is a very common issue as well, sometimes the latency between tasks. Error rate, we want to make sure DAGs were actually succeeding. It would be no use if we reduced the DAG runtime to 1/10, but then it just failed. And we also knew that CPU and memory were constant concerns from our users. So those are things we wanted to track. There could be many other metrics we could track. There were situations where we've seen in Airflow where the tasks have a long queue time. For instance, this is a common problem. You may want to optimize for caching, garbage collection, throttling, many things you could try to optimize. We did not cover all these areas. We chose some of those that we thought would be more applicable for initial setup of the benchmark. We also wanted to have some sort of statistical significance. None of us are specialized in statistics, but we knew that to run once wasn't representative enough, so we want to have a tooling that would allow us to repeat and reproduce. We also want to be sure that we were checking standard deviations and things. Let's say there was something going on, either in the cloud or in the computer being used. We wanted to be able to isolate those cases. And then we are currently leveraging standard deviation, and we want to still leverage percentiles. So the actual implementation. Our experiment goal was, we want to understand how Cosmos 110, so this tool that goes from a dbt pipeline into an Airflow DAG, how the performance of this tool compared to running the dbt CLI by itself, or if you were paying for a private service that's called dbt Cloud to run this tool, these SQL pipelines. And we wanted to understand specifically what happens if we run the dbt commands, just the command, one command for the whole pipeline, or if you broke down using the dbt CLI, one command per model, per node of the pipeline. Because this is what Cosmos does. It breaks down that pipeline into multiple commands. So we wanted to have those as baselines to understand where we could potentially improve the tool. So this is an example. These are different ways of running the same pipeline using dbt. In the first one, you run dbt build. It will load all the seeds. It will run all the transformations, run the tests. In the second one, we are decomposing based on what the nodes do. So first we load the seeds, then we run the transformations, then we check the tests if things are passing. And in the last case, we are having one command to run for each of those seeds, each of the models, and each of the tests. So the first goal was, which of these approaches is more efficient, which is quicker, and then we could understand some of the problems we were facing. Here you can see the equivalent Airflow DAG for each of those granularities. So we took into account pipeline execution time, memory consumption, and CPU. The first step we did was with dbt Cloud. So we created a trial account. We set up a project using their UI. We triggered the dbt Cloud job, and then we collected the time. We couldn't collect CPU and other things. This was a bit more manual than we would like, but at least we tried to keep this pre-process, run, and post-process. The second step we did was, what if we wanted to validate the dbt core, the CLI, locally? We didn't want to use our own computers, so we thought, how could we isolate and have a fair comparison of running this with running Airflow? Well, as fair as it can be. So we thought, okay, let's have a Kubernetes cluster. Anyone could set the Kubernetes cluster as they prefer. If you want to use a managed service, you can use a managed. If you want to host your own, if you want to run a kind cluster locally, you could set those. We made sure that in the Kubernetes jobs we created, we set resource limits. So we try to limit the memory and CPU so the test was consistent across the different use cases we implemented. We installed Prometheus, so we could try to track how was the utilization of resources by the pods being evaluated. In this particular case, we created a Kubernetes job that would run the dbt command. And after that, we collected the metrics, and then it teared down the infrastructure. For Airflow, we did two approaches. One of the approaches was, what if we wanted to try to compare Airflow as close to dbt as possible? If you were running an Airflow pipeline in a single command line, how many people have used the Airflow DAGs test command? Okay, so we have more or less 1/5, no, much less, 1/10 of the audience. So this is actually one of my favorite Airflow commands. When I'm writing DAGs, I really like to just be able to, in the command line, to execute, to be able to add a breakpoint, to identify if something is going wrong there. And dbt DAGs Airflow DAGs test is your command to do this sort of troubleshooting. So it does not spin up a proper Airflow infrastructure. You don't have all the distributed systems and components. Everything runs within the same command, same process. But it does allow you to check if the DAG is working or not, unless it's more complex. If you're leveraging sensors, the behavior may not be desired. If you want to try to play with some listeners and sensors, it may be more complicated. But if you have tasks that are quite simple and straightforward, like this one's transformations in a database, you can use it and it's really good. So one of the first attempts was to do the Airflow DAGs test command for this Cosmos DAGs. And the other was to actually use Airflow Helm chart to spin up an Airflow environment, configure it with some parameters, and then try to trigger the job there. So these were the things we were comparing. All that we're showing here is available in an open source repository. We do not believe this code is like a magnificent example of software engineering or the best of all. But we do believe this is a first step on the community having open discussions based on source code of how we may want to do benchmarks. And if this is not the way, let's discuss what's a better way. And then perhaps we can all try to use the similar tooling, and then we can check if we're migrating to Airflow 3, does that make our DAGs faster, slower, why? So it's important that we have these discussions. They can affect the business. So from a results perspective, when we run this particular pipeline that I discussed before in dbt Cloud, you can see that it was run in more or less 5 minutes and 10 seconds. This is an average among several runs. We couldn't set CPU and memory utilization, but you can get an idea. So around 5 minutes to run this pipeline in a commercial platform. When we tried to use the open source dbt core CLI locally, when we first run everything with a single command, that was that first example I showed that was in the left side of the screen, we were able to run in a very similar speed. So the feedback we were receiving from our customers to run dbt CLI locally is very efficient. It's as good as the commercial offering for this particular pipeline. So it also took around 5 minutes. And then what we realized, where was one of our source problems, if you instead try to run one dbt command for each of the transformations and each of the tests, this time increased significantly. It was 6 times slower. It was terrible. So we said, oh my God, what are we going to do? That's what Cosmos is doing. Of course, people are complaining. The tool wasn't designed to be efficient running in such a split way. So we said, okay, but let's see how things are within Airflow. So the first attempt was to use this Airflow DAGs test command. We used 2 strategies. One of them was to run using one single Cosmos operator to run the whole dbt pipeline, similar to running dbt build. And the other one was to use Cosmos standard way, where you break one dbt model per task. You can see the times were quite comparable to the other times we observed. If dbt was run in a single task, in a single process, we had a performance very close. It was around 5 minutes, somewhere between 5 and 6, People can survive with this tiny delay for a distributed orchestration system that may be worth. But then 27 minutes, that's quite slow. So at one point, to have the granularity and observability in Airflow justifies, but does it justify being 6 times slower? Perhaps not. So we also then run using Airflow DAGs trigger within the Airflow Helm chart setup. And these were the times when you don't use the Airflow DAGs test. We were using 2 worker nodes, so we could parallelize a bit the load, so it was a bit quicker. But it's still 3 times slower than a single command run. We can't be that bad. So if you're wondering what we did about these performance issues, tomorrow, Pankaj Koch, Pankaj Singh and I will be discussing about some strategies we used based on the benchmark we created to improve Cosmos performance, so it could be as quick as dbt. So if you're around tomorrow, 12 o'clock, we will discuss the details of this. But the spoiler is we were able to manage to have the thing running in Airflow, having granularity of multiple tasks, allowing people to retry individual tasks, but with a performance similar to dbt. Next steps. This is the repo. We haven't been able to invest as much as we would like. We would like to make it more configurable. At the moment, to be able to configure tests, you need to create a Kubernetes job specification, and then you manually update a file or use an environment variable to say which scenarios you're comparing. We would like to make something better, something easier to use, something that could be easily extended to non-Cosmos DAGs, to any DAGs, that hopefully if we had a benchmark CLI, if we could perhaps extend Breeze from Airflow, that could be a nice way of having things. We adopted some shortcuts to implement this. So as you saw, we used the Airflow DAGs trigger, which is a command invoked from within one of the pods. We would like to leverage Airflow 3 APIs to have a cleaner interface. At the moment, we're printing the results and those metrics in the terminal, and then we copy them to a spreadsheet. Very shameful. But we want to improve this, so we export into JSON or a database that have a cleaner interface, points for improvement. We would love to integrate this to Cosmos. So for instance, we can, every time we release an alpha or something, we could run these benchmarks, and then we could have like alarms saying, oh my God, things are getting 30% slower, stop, you can't release this. We want to collect more metrics, and we want to, the same idea of setting up, running things, and then tear down. We can do them in many places. Rahul mentioned about the importance of running things in an environment as close to production as possible. We want to make it easy for people to compare performance in Astro or in your own managed Airflow or anywhere you want to run. So we believe we should be able to do this analysis. People should be able to compare and reproduce and discuss these problems openly. So takeaways. Performance and benchmark is not just about running stress tests and running multiple times and many times or having many DAGs competing. We believe it's about fair, reproducible, meaningful experiments which anyone would be able to use, and we could guide decision making. Many people may claim that using Airflow DAGs tests, for instance, maybe that's not a very fair comparison with a proper Airflow deployment, but then let's say you have 3 versions of the same DAG. If you're using exactly the same tooling with allocating the same amount of memory and CPU, perhaps that's good enough because you're constraining everyone to be running the same way. So sometimes simple approaches can help you identifying problems, and it could be used, you could have that running in your CI even. It can be quite simple to use. Some numbers may be better than no numbers. And we do believe we need an open source standard to run benchmarks on Airflow. When Rahul asked how many people were running benchmarks, how long does it take to run your DAGs, many people were not sure. And this can affect your business a lot. So let's try to define a standard, a pattern, so we can run this and make sure that Airflow can be leading the orchestration tools as it has been. For anyone who's interested in building dynamic DAGs with dbt, Tamara, a fellow astronomer, recently put lots of effort and wrote a book. This book is free. It's the best guide to run dbt in Airflow that I've seen. It has almost 100 pages. You can download via this QR code or this URL. If for any reason you're having issues downloading, reach out to me, and I will make sure you have a copy of the PDF. So this is a very, very good resource. If you haven't yet, please answer the survey, Airflow survey. The more people that answer, we can identify most common issues in the community and improve Airflow. That's really, really used into account to plan the roadmap.